Hello and welcome back. This is a video over the 6.4 notes, and what we're going to be talking about today are rational expressions, equations, and functions. All right, so what we were doing before is we were just simplifying rational expressions. What we're going to be doing now is we're going to be solving rational equations. So the difference, and let's just kind of talk here for a second, an equation has an equal sign. Has an equal sign, okay, and we solve for the variable. All right, so we solve for the variable. All right. In an expression, all right, we're just doing some vocab here. In an expression, what you have is no equal sign, all right, to make it simple. And so you don't, when you have an expression, you don't solve for a variable. All right, typically what you do is you simplify expressions. Okay. All right. Now, the thing that's kind of unique about this is that everything that we did with an expression, we have to use when we solve equations. Okay, so it's a little bit, it's one of those building blocks. Like you have to understand expressions, how to simplify them in order to solve equations. Okay, so what I want to do here, this list of 4 things shows you how to solve rational equations. Okay, now the big thing what we're going to do is we're going to state restrictions on all of our denominators. And then I'm going to show you guys how to solve. That's step 2 and 3. And then step 4 is checking our answers against our restrictions, okay? So if we notice a contradiction, then we remove that solution from our final answer. So what I want to do is this, okay? Let's just take a look at this first one. All right, example, solve for the following for x. So you've got this equation, and these are just fractions. So rational equations are equations that involve fractions that you have to solve. Okay, it's really fun. All right. On here, what I have is 4 over x is equal to 5 over x minus 1/2. And what we're trying to do is we want to find the value of x that makes this true. However, we first want to look at our restrictions. All right. And remember what we do is we take our denominators and we set our denominators equal to 0. Now, we only do that when we have variables. And this one's pretty easy. I'm just going to take our denominator of x, okay, that's the only variable that we have, and I'm going to set that equal to 0, okay? This is my restriction. This value here makes the equation undefined. So what we can't have happen, x basically cannot equal 0, all right? So if we get that as an answer, and sometimes what will happen is we'll get those as answers algebraically, but they don't work for the actual equation, all right? So now the first step that I want to do is I want to take all of this and I'm going to multiply this by my common denominator. So my common denominator, I'm going to label that as CD, is going to end up being 2x. Okay, so my first step is to multiply. All right, I want to multiply by the common denominator, okay? And so what I'm going to do is this, all right? My common denominator is 2x. I'm going to do 2x times 4 over x, and that's going to be equal to 2x times 5 over x minus 2x times 1/2. Okay, I'm going to put all of these over 1 here, but we want to think about why I'm doing this. What I do when I do this is going to eliminate all of the fractions. Okay, so we have to think about what things divide out at this point. So my x's are going to divide out here, my x's are going to divide out here, and my 2's are going to divide out here. So what you're left with in the end is just this. It's going to be 2 times 4 is equal to, what do we got? 2 times 5 minus x times 1. And so what I've done is I've eliminated all of these fractions, and I just have a normal equation that we can solve. So here, all right, if I do 2 times 4, that's going to give me 8, is equal to 10. 2 times 5 is 10, and then x times 1 is just x, so minus x. All right, and so what I can do here is I can subtract both sides by 10, and I'm going to get negative 2 is equal to negative x. Now, when I have that negative there, I just want to divide both sides by a negative 1. All right, and so the negatives divide out, and then I just get that x is equal to positive 2. Okay, now we have to check this with our restriction. All right, and in that restriction, we know that x cannot equal 0. So if x equals 2, that means that we're good. All right, and that's the value that would make that true. All right. So let's go ahead and take a look at the next one. These do get a little bit more complicated. And I've just got these 4. Okay, so let's take a look at our restrictions first. All right, our restrictions, I'm going to write this out here. Is that x, if I set x minus 5, that's my, and I have a common denominator of x minus 5. So I set my denominators equal to 0, solve for x. Okay, add 5. I'm going to get that x is equal to 5. Okay, this makes my equation undefined. Makes my equation undefined. Okay, and so because that makes it undefined, x cannot equal 5. All right, now if we get 5 as an answer, then that's what we'll have. Now this one is a little unique. And the reason why this one is unique is because we have a proportion. I have one fraction equal to another one. Now we could do the same thing that we got before and just multiply everything by x minus 5. And so let's do this 2 ways. All right, let's do this one way. So first method, just so you guys can see. And we'll get the same thing doing it either way. So first method, let's just write it out. 4 over x minus 5 is equal to x minus 1 over x minus 5. Now, over here, what I notice is that my common denominator, CD, is just x minus 5. And we have a common denominator, all right? So if I multiply everything by x minus 5 and multiply this by x minus 5, then these things are going to divide out. All right, and we're just going to get rid of that factor of x minus 5. Then what we do is we get 4 is equal to x minus 1. Now if I just add 1 to both sides, okay, what are we going to get? We're going to get that x is equal to 5. All right, and so remember though, x cannot equal 5. Okay, so what I have here, this is what we call an extraneous solution. All right, and the reason why it's called extraneous is because we got it algebraically, but it doesn't actually work with what we have. Okay. Now, the other thing that I want to do, first method is what we did just by multiplying by the common denominator, right? What I want to do is a second method, and that's by solving a proportion. All right, so let me do 4 over x minus 5 is equal to x minus 1 over x minus 5. Now, if I solve this as a proportion, that means I cross multiply. Okay, and so all I'm going to do here is I'm going to do 4 times x minus 5 is equal to x minus 1 times x minus 5. All right, and let's go ahead and distribute our 4 here. So we're going to get 4x minus 20 is equal to, and then here we need to multiply all this out. We're going to get x squared minus an x minus 5x, and then plus 5. Okay, and so what we have is a quadratic. So this is a little bit more complicated to solve. And so what I want to do is combine my like terms here and here. So I get 4x minus 20 is equal to x squared minus 6x plus 5. I'm going to subtract 4x from both sides. I'm going to add 20 to both sides because what I want to do is I want to get everything set equal to 0. Okay, so 0 is equal to x squared minus 10x and then plus 25. Okay, so what I want to do is factor this, and two numbers that multiply to positive 25 but add to negative 10 is just going to be negative 5 and negative 5. So x minus 5 times x minus 5, and that's equal to 0. And so since both of those factors are the same, and if I set one of them equal to 0, x minus 5 equals 0, I get x is equal to 5. So how we say that, so we get the same thing, all right? One was definitely way easier than the other. Okay, the first method was way easier. We get the same thing here and here, okay? But we still have to just say that it's an extraneous solution. So x is equal to 5, but it's extraneous. Okay, you could also make the claim that there is no solution, but that's what we got, all right? Okay, let's take a look at part C. Now, what I want to do on part C is find my common denominator. Now, my common denominator from here, I need to factor everything in order to figure that out. So let's write our first part here, 5 over x minus 3 minus 30 over x squared minus 9. That factors to x minus 3 times x plus 3. And then that's equal to 1. All right? So now what I want to do is, I want to multiply everything by my common denominator. All right, I'm going to put this over 1. So my common denominator is just going to be x minus 3 times x plus 3, all right? So I'm going to multiply this whole thing over here by x minus 3 times x plus 3. Okay, I'm going to multiply this one by x minus 3 times x plus 3, all right? And then on this part here, I'm going to multiply this by x minus 3 times x plus 3, all right? Now, let's see what divides out. And that's the point, that's why we do this, is because it should get rid of all of our denominators. So what I notice here is that x minus 3's divide out here. I notice that everything divides out on this term, and then nothing divides out here. So what we're left with is this, all right? We're going to get x plus 3 times 5 minus 30 is equal to 1 times all that, which is just going to be x minus 3 times x plus 3. Okay, at this point, what I want to do is I want to distribute this 5 into here and here. So I'm going to get 5x plus 15 minus 30 is equal to, and I'm just going to go ahead and multiply this as well. And this is easy to multiply. We're just going to get x squared minus 9. Okay, if I multiply those binomials, all right? The next thing I want to do is combine my like terms. So I've got 15 minus 30. It's going to give me negative 15. So I've got 5x minus 15 is equal to x squared minus 9. Now what I'm going to do is I'm going to get all these terms on one side and set it equal to 0 because I have a quadratic. And I know that because I have an x squared, okay? So, all right, so if I set all this equal to 0, all right, so I'm going to subtract 5x from both sides. I'm going to add 15 to both sides. So here's what we get as a result. We're going to get 0 is equal to x squared minus 5x, and then negative 9 plus 15 is going to give me positive 6. Now this factors to x plus 6. Okay, and so this should actually be x minus 6 instead, and then x plus 1. Okay, now what I want to do to solve this, I set each of these factors equal to 0. So I've got x minus 6 is equal to 0. So, and then I've got x plus 1 is equal to 0. So if I add 6 to both sides, I get that x is equal to 6. And if I subtract 1 from both sides, I get x is equal to -1. So now what I have to do is I have to check these against my restrictions, okay? And so if we think of our restrictions, let's write this down up here.
Where is that?
Okay. So we need to take our denominators, which was x minus 3, set it equal to 0, and x plus 3, set it equal to 0. So our restrictions is that x cannot be 3 or -3, okay? Now, the cool thing is that the answers that we got here don't really matter so much, okay? Because they're not 3 or -3, so these are our solutions, okay? Okay, let's look at part D. I kind of rewrote it over here, so let's do one of these, if you ran out of room like I did. Okay. Now what I want to do is I'm going to rewrite this whole thing in part D. So I'm going to write x over x minus 4 minus 2 over x plus 8 is equal to 63 over, and let's factor that, because that's what's going to help me figure out my common denominator. So I've got, so it's going to give me positive 8 and -4. And the cool thing about these is that a lot of times when you have these rational expressions, if you're trying to figure out whether or not how to factor this, look at the other denominators, look at all of your expressions, because it'll kind of tip you off as to what the factors are. Okay, so now my common denominator is just the product of those two other denominators. So my common denominator is going to be x plus 8 times x minus 4. So we're going to multiply everything by that common denominator. Okay, so let me rewrite this. So I've got x plus 8 times x minus 4. Okay, I'm going to multiply that by x over x minus 4 minus, I'm going to do x plus 8 times x minus 4. I'm going to multiply that by 2 over x plus 8. All right, and that's going to equal 63 over x plus 8 times x minus 4. I'm going to multiply that by x plus 8, x minus 4. Okay, so now we got to look and see what divides out. So my x minus 4s are going to divide out. My x plus 8s are going to divide out, and then everything's going to divide out over here. So now what you're left with is this. Okay, you've got x plus 8 times x minus x minus 4 times 2, and that's just going to equal 63. All right, so now let's distribute everything that we've got. So I'm going to distribute this x, so it's going to give me x squared plus 8x. And then, oh, this is where it gets a little tricky. This is really a -2. Let's go ahead and distribute that too. This is going to give me minus 2x and then plus 8. I'm kind of skipping a couple steps there. The reason why is because I'm subtracting this quantity. So I have to distribute that negative as well as the 2. That's how we get the -2x and then the positive 8. Okay. Let's combine our like terms here and let's solve. So I've got x squared, 8x minus 2x gives me 6x plus 8, and that's equal to 63. Let's go ahead and subtract 63 from both sides and set this all equal to 0. So I get x squared plus 6x minus 55, and that's going to equal 0. So now what I have, I want to factor that. Okay, and solve. So two numbers that multiply to -55 but add to 6 is going to give me, well, the only numbers that multiply to -55 is some combination of 5 and 11. Okay, so if I do positive 11 and -5, that should give me 6. So I've got x minus 11, x plus 5, and set that equal to 0. Okay, so now if I set each of these equal to 0, x minus 11 equals 0, x plus 5 equals 0. This means that x is equal to 11, and x is equal to negative 5. Now, we need to think about our restrictions. We didn't do that. All right, so our restrictions, take our denominators, set those equal to 0, so you get x plus 8 equals 0 and x minus 4 equals 0. You get that x is equal to negative 8, x is equal to 4. These are my restrictions. Okay, because your denominators can't be 0. So, because that didn't hit any of our restrictions, we're good. These are our answers. All right, kind of nice. Okay, let's take a look at that very, very, very last one. Okay. And what we're going to do is we're going to go ahead and not do this one. This one doesn't work out nice and neat. We could do this and do it graphically, but I don't want to do it. So go ahead and get started on your homework, and we'll see you in a bit. Thanks a lot. Bye.